recent years, all localities have conscientiously implemented the spirit of the important instructions of the Ministry of Housing and Urban Rural Development on the construction of smart cities and adopted a variety of measures to promote the construction of smart cities, which has played an important role in alleviating urban waterlogging. However, some cities have problems such as insufficient understanding, misunderstanding, and unsystematic implementation of smart city construction affect the effectiveness of smart city construction. In alignment with the outline of the 14th Five-Year Plan, it is imperative to robustly advance the construction for smart cities. This entails bolstering the urban hydraulic infrastructure to effectively manage flood discharge and meticulously govern the construction and subsequent maintenance of related projects. The stipulations are henceforth communicated as follows: enhancement of construction governance. The calculation of the investment quantum for smart city development necessitates pragmatism. Capital allocation for core projects such as structures, thoroughfares, and environmental rectification must be delineated from the budget allotted for smart city initiatives. During the design phase, architects are supposed to integrate smart city constructions into their schematic reviews, with a thorough vetting of construction drawing designs against applicable compulsory standards within the construction licensing and final acceptance. Adherence to smart city construction mandates should be prioritized as a focal point for review and oversight. The principle of smart city construction should be integrated throughout the entire spectrum of urban planning and construction management. This entails incorporating the objectives, metrics, and configuration of key smart city facilities into the pertinent planning and approval processes. Newly proposed and expansion projects must rigorously adhere to the standards set forth in smart city construction. Any projects that do not necessitate alteration and that are submitted for approval must not arbitrarily lower the established planning indicators. Furthermore, renovation projects should take into comprehensive consideration the necessities of smart city construction, the specific measures for the construction of smart cities should be in line with the current situation and planning goals of the city. The technical route should be compared, and the effects of various measures should be demonstrated, so as to avoid listing and piling up engineering project without analysis and demonstration. The same technical measures and the same design parameters should not be used in different construction projects. Strengthening construction management. Smart city construction projects should be constructed in strict accordance with the drawings, implement the vertical requirements of the site, ensure the continuous and smooth collection of rainwater, and control soil erosion, strengthen the quality inspection and record keeping for underground pipelines and detention facilities, etc. The construction of a smart city should take into account natural topography, river and lake water systems, elevation gradients, and the layout of drainage facilities, among other factors. To rationally divide drainage areas and align with the natural texture, topography, and water system relationships, high water goes high, low water goes low. We should avoid dividing areas with higher elevations and easier drainage into the same drainage area as low-lying areas. and prevent dividing the boundaries of urban planning control units and administrative divisions into drainage areas. The construction of smart cities should strengthen the integrated design and whole process coordination of drainage, landscaping, architecture, roads, and other disciplines, give priority to the use of natural forces for drainage, ensure economy and applicability, and realize the coordination between landscape effect and the surrounding environment. Avoid considering the problem only from a single professional point of view, and cannot be patched by the drainage engineering major after the design scheme of buildings, roads, gardens, and other designs is determined. Carry out operations and maintenance tasks. Specify the entity tasked with the operation and maintenance of relevant facilities within the smart city framework. Allocate funds appropriately. Conduct thorough daily maintenance and guarantee the optimal functionality of these facilities. Strive to prevent scenarios where there is no accountable party, insufficient financial support, or other issues. Once the facilities are established, unauthorized demolition, alteration, illegal occupation, or damage should be strictly prohibited. Establish a daily maintenance system for rainwater facilities, a pre-storm inspection system, an emergency response system, and an efficiency monitoring system for rainwater facilities in a smart city. Train professional operators to have specialized technical knowledge in the operation and maintenance management of smart city facilities. Carry out evaluation scientifically. Establish and improve the performance evaluation mechanism for smart city construction. Investigate the problems existing in the work item by item, and highlight the goals of urban waterlogging mitigation, people's satisfaction and benefit, and fund use efficiency. Avoid taking the number of projects and the scale of investment as work results. Strengthen the training of smart city construction management and technical personnel to ensure that the construction of smart city is not out of shape. Actively explore the forms of publicity that the masses like to see. Strive for the public's understanding, support and cooperation for the construction and transformation of smart cities. Avoid the smart city omnipotence theory and smart city useless theory, and prohibit false propaganda or exaggerated publicity. The basic requirements for the maintenance and management of smart cities, low-impact development facilities within public projects, are sustained and overseen by pertinent departments including responsible for urban roadways, drainage systems, and green spaces in accordance with respective allocations of duties, maintenance and oversight of all other low-impact development stormwater facilities fall under the purview of the facility's proprietor or their designated agent. It is necessary to establish and improve the maintenance management system and operating procedures of low-impact development facilities, allocate full-time management personnel and corresponding monitoring means, and strengthen professional and technical training for managers and operators. The Maintenance and Management Department of low-impact development rainwater facilities should do well in the overhaul and maintenance management of the facilities before and during the rainy season to ensure the normal and safe operation of the facilities. The Maintenance Management Division of the Low-Impact Development Facility is tasked with monitoring and assessing the efficacy of the facility to guarantee the uninterrupted operation of its functions. It is necessary to strengthen the establishment of the database of low-impact development facilities and the application of information technology, carry out scientific planning and design through digital information technology, and provide scientific support for the construction and operation of low-impact development rainwater systems. More efforts should be made to raise public awareness of the importance of rainwater control and utilization in the construction of smart cities, low-impact development, green buildings, urban water conservation, water ecological restoration, and flood prevention and control. Public participation should be encouraged in the construction, operation, and maintenance of low-impact development facilities.